Okay, Habeeb, you can take it away.
Right. Hi, everyone, and good morning, good afternoon, and good evening, wherever you are joining us from around the world. I'm so excited to be on this call today, and I am glad to welcome you to the 2024 Green Sustainability Trends, World Tech Chat, hosted by World Technology Partner. My name is Habeeb, and I am the co-founder and head of digital media for DMi Digital Marketing Agency. DMi Digital Marketing Agency is a leading marketing agency in Nigeria and in the United Kingdom. And what we do is that we help businesses, regarding their online feasibilities. We do website development, social media marketing, SEO, and a lot of other digital marketing services. Right. And I'm also a member of their advisory board for World Technology Partner. Right. I've been working along with Paul for the past 2 years, closing to 3 years now. So yeah, I welcome you all on board. I'm so glad again to have you. So before we dive into the presentation today, let me try to give you an overview of what we do at World Technology Partner. So we are actually an independent finance LLC headquartered outside Princeton, New Jersey. So we're dedicated to promoting technology worldwide through various initiatives, including competitions, aiming at showcasing the work of students like you, right, in technology and sciences. So today, we are going to be exploring the 4 green sustainability trend and solution that has been developed by students in Egypt, Nigeria, South Africa, so to discuss their innovative solution with us here on the call. So please note that this call, is going to be recorded, and later we are going to put it on our website. So please, if you don't want you are not pleased with the recording, do well not to ask any questions. So during the course of this webinar. As some of you might know, this is the second year that we have been, having these competitions, right? And our first was last year when we awarded 6 students. We awarded them $75 each for their submissions, right? We actually received quite a number of submissions, right? But after the whole lot of to vet them, right, we came up with the winners and we awarded them $75 each. So over the past 2 months, we have invited submissions from individual and team with significant experience in sustainability across various regions, including Africa, Asia, Eastern Europe, Middle East, and the Americas. Our esteemed selection committee comprised of professionals and educators from diverse backgrounds in Albania, India, Nigeria, Panama, and the US, and they have reviewed this submission and they were able to come up with the, 4 of the winners that are going to be presenting with us today. They're going to be presenting their solution to us today. So fortunately, we have also been able to increase the amount of honorarium that we actually give the winner. So we give 10 to NVIDIA. So we increased from $75 to $125 for the 3rd place winner, and $250 for the 2nd place winner, and $500 for the 1st place winner. So this is actually a significant improvement in our work, and great job for doing this poll. So as with all competition that what technology partner holds, submission were evaluated based on United States sustainable goals. Winners have been divided into 2 categories. On Tuesday, we've heard the environmental engineering presentations, and today we are presenting something new which is going to focus on the organic architecture. So American architect Frank Lloyd Wright coined these terms, the organic architecture terms, earlier in his career, approximately over 100 years ago. So and this man believed in designing in harmony with humanity and the environment, a philosophy he labeled organic architecture. He went ahead and designed a falling waters, a private house outside of Pittsburgh, the Imperial Hotel in Tokyo, and the museum in the Guggenheim Museum in the New York City. So at this juncture, I'm going to be walking you through the schedule of today's webinar, right? So each presenter will have 10 minutes each to present to us what they have for us, right? To present their solution to us. And after that, they are going to have 3 more minutes for them to take question and answers, right? So that is how this webinar is going to be structured today. So, and I'm pleased that we are going to be starting with the 3rd place winner. So without further ado, permit me to present to you the 3rd place winner for this year, 2024 Green Sustainability Trends. So ladies and gentlemen, I'm happy and glad to present to you Chiwetalu, Nenechi, and Precious Chinenye. They are the graduate and undergraduate students, Bioenergy and Architecture from Federal University of Technology, Owerri, Nigeria. So they are going to be discussing with us today on the topic, integrating biophilic design for sustainable workplaces amidst the toxic emission in oil field installations. So ladies and gentlemen, I'm going to be leaving mic for Chiwetalu and Precious for them to present their idea with us. Are you there?
Yes, we are here. Good evening, everyone. Good
evening. Are you in a position to open your camera?
My partner needs to say hi. Naya, could you say hi? You are muted.
Hello.
Hi.
Okay, so let me share my screen if that's okay by everyone. Good evening, everyone from Nigeria. We are Chiwetalu, Nenechi former, and Agaworo Precious Chinenye, my master's students in African Center of Excellence in Future Energies and Electrochemical Systems, studying bioenergy, and my partner is an undergrad student in Federal University of Technology, where we're studying architecture. So we want to present on integrating biophilic designs for sustainable workspaces amidst toxic emissions in oil field installations. So first of all, what are these biophilic designs? Can everyone hear me? Sorry.
Yes.
Okay. Biophilic designs are generally concepts of nature which are integrated into built environments, and they are used in spaces such as the hospitals, the schools, and the airports, in our homes, hotels. And these environments that include biophilic designs are used to achieve a desired effect, aside from creating aesthetics or enhancing the aesthetics of the environment. They also bring effects such as enhanced cognitive functions, calmness, reduce fatigues. So incorporating these designs in industrial spaces are actually unique exactly common. And we want to fill that gap because we believe that by applying biophilic designs into the spaces, it helps the workers there that are usually faced with repetitive tasks and tasks that are usually strenuous to also experience this calming effects and enhance cognitive functions, which is necessarily in their work, and also to help the environment in a sustainable manner. So incorporating this into refineries, we are kind of challenging the traditional design paradigms by putting the health of these workers at the front line. And this innovative approach helps us to improve the air quality and increase productivity by enhancing their cognitive functions. And they are particularly valuable in very potentially hazardous environments such as these oil field installations. So for our problem statement, we know that the workers in these oil refineries are always exposed to toxic emissions, especially those emissions that are exposed into air, and they have been linked to significant health risks. We have done extensive research and we have seen that some studies quantifies these health impacts by having over 700 premature deaths, and other studies have found that the refinery workers have suffered from fatigue, headache, difficulty in breathing, and these alarming figures have prompted us to see another light from the traditional designs, and we could incorporate this biophilic designs, which is a way of bringing organic architecture into the oil patch, and by increasing the health and also the morale of workers, let them see a reason to come to work happy, not just coming for the salary. And also this design will also help us to mitigate the environmental impacts and to create a good ecological balance and a sustainability effect. Then for our objectives, we'll extensive literature review, and this literature review has given us an insight to integrate these designs into existing oil refineries. Our second objective is to improve the employee health and productivity, and to reduce environmental impacts of air pollution, and also to enhance the visual aesthetics of the environment. This is a very simple flow chart of what we plan to do, which is extensive literature review, as I've mentioned, the study of existing biophilic designs into built environments, which are the hospitals and the other places that I've mentioned, and also to evaluate the existing conditions of the oil refinery, to prioritize the biophilic design strategies. What is suitable for this place? Is it the P6, which is on diffuse lights, diffuse and dynamic lights? Is it pattern 7, which is connection with natural systems? Is it pattern 12, refuge, prospect, mysteries, and the rest? And when we get that, we'll now go into our design and implementation. Then after the implementation, we will monitor and reevaluate. Then according to the reviews we've done, the research we've done, we've seen that biophilic designs are built most especially into homes, hotels, hospitals, schools, amusement park, airports, offices, but they haven't actually been carried out in being implemented rather into facilities like industrial facilities. And this is the gap we hope to fill. You can see the pie charts whereby there's an uneven distribution of the integration of biophilic designs into these already built spaces. So my partner is going to take us on this integration and why we are going to integrate this into oil field installations. Naya?
Yes, thank you very much, Chiwetalu. So I'm going to be speaking on the drawings here. We are proposing to integrate biophilic design, focusing on P1, which is visual. Examples of those indoor spaces include cafeteria, resting room, and conference rooms. And examples of those outdoor spaces include the walkways and the drive-throughs. For the indoor spaces, we propose to use allergy-friendly plants which are indigenous to the ecosystem in that environment. And for the outdoor spaces, we propose to use plants with high air pollution tolerance capacity, which can serve as carbon capturers and sequesters, and also to enhance the aesthetics of the outdoor and indoor environments. Thank you very much.
Okay, so I'll take it from there, and we have the key beneficiary of this research, which are the employees, by helping them in their health and enhancing their cognitive functions. Also, will be enhancing the environment, and also will be enhancing the environment by companies who want to maintain their environmental reputation. So they wouldn't want to be seen as people that destroy the ecosystems. So this also will be beneficial to them and also to the community in that environment by making them inclusive, to bring the indigenous plants to help us enhance the greenery of both the indoor and the outdoor spaces. And our relevant sustainable development goals, we have 4 major SDGs our research resonates with, which is sustainable development 3, 11, 13, and 15. The 3 is talking on good health and well-being, which are very crucial to the workers working there. And also, it also enhances sustainable cities and communities, and also encourage climate action, and also encourage life, which also encourages biodiversity. Thank you, everyone. Naya?
Thank you, everyone.
Excellent. Thank you so much for the
Hello, everyone. Can you hear me?
Chiwetalu.
Yes. Okay. So, yeah. Naya,
Hello?
kindly thank the team. We're done.
Thank you very much. Thank you very much for this opportunity.
Yes,
Hello,
perfect.
we can hear you.
We can. Okay, perfect. So thank you for your presentation. So the ground is open for anyone that has questions to ask. If there's any questions, just open your mic and go on, or you can.
Or raise your hand so we know that you want to ask a question. Okay, since there does not seem to be any questions, let's move ahead. Habeeb.
Okay, awesome. So, Chiwetalu, you can stop sharing from your hand so that the next presenter will be able to present.
Okay, all right. Thank you.
Yeah.
Thank you very much.
You're welcome. So, ladies and gentlemen, we've heard from the third place winner, from the Federal University of Technology, Owerri, Nigeria. And right away, we are going to be going down to the second place winner, which is Tushomo Viri, PhD in Architectural Philosophy, University of Cape Town, South Africa. He will be talking on the investigation of viable methods to adopt water-sensitive design in the context of AMBAG, South Africa Fair Community Participation. Chisomo, are you there?
Hello, yes, I am. I'm sorry, I'm just having a bit of an issue with my camera, but yes, I'm here. Sorry.
Perfect. Thank you so much for joining us today.
Sure.
And you could load your presentation into Google Meet.
Okay, we'll do.
You have 10 minutes for your presentation. Thank you.
All right. I hope you can all see my screen.
Yeah,
Yes.
Fantastic. Okay, thank you so much. Hello, my name is Chisomo Piri, and I will be discussing my research on investigating viable methods to adopt water-sensitive design in Hangberg, Cape Town, South Africa. So the research that I looked at Hangberg, particularly because it's an area that's endemic, that has a prevalence of issues endemic with most of the low-income areas in South Africa. There's a strong state of inequality, there's poor resource management, and of course resources are unfairly distributed because of the history of apartheid and segregation. And whilst this is a deep problem that's got deep-rooted effects, I believe there is also an opportunity for a new direction, especially when we talk about sustainable African societies, and South Africa as part of that sustainable African society. And of course, the idea is simply to find ways of implementing these sustainable systems to increase basic amenities whilst keeping costs low. So as you can see, the area of Hangberg, the area of Hout Bay in general, is an extremely diverse area. There is a huge disparity between the areas that are low income and areas that are affluent. As you can see in this image of Seaview and Hangberg, which are neighboring districts. So the issues endemic with inequality, they revolve around differences in engagement levels, difference in inclusion. There's a level of difficulty in accessing health and security. And of course, integration is extremely difficult if you are starting off in different areas and at different levels of accessibility. And of course, there is a lower willingness to invest in an area that has these issues. So we need to then look at a shift from a shallow ecology where man is above the environment and there is a reliance on technical solutions and the management of the environment as a administrative task. Instead, we need to look at a deep ecology where man is part of the environment and has veneration for life, all life, and attempts to achieve a complete symbiosis. So with that aim in mind, with an aim towards an environmental, equitable economic process, I managed to identify water-sensitive design as part of permaculture, part of regenerative design, but with the addition of inclusive processes, we can then achieve a more livable architecture, a livable approach to architecture. And this is a diagram where I look at theoretically how livable architecture would sit within.
Hello, Mr. Chairman. So your presentation is not audible, and then we cannot catch up with the slides.
Oh.
So if you can please adjust the audio and try to make the presentation slides available.
Okay, will do. Can you hear me now?
Yes, we can hear you loud and clear.
Fantastic. All right. So as you can see, this is a diagram where I look at the theory involved in identifying where livable architecture sits. It is an aspect of sustainable design. It is something that I imagine is easily connected to water-sensitive design, environmental behavioral studies, and participation action research, but it kind of sits at the junction of all of these elements whilst being critical to the region, and of course, speaking to the natural environment, local community, modern technologies, and local traditions. And the approach that I took, the methodology that was adopted, was to look at 4 steps towards a livable architecture where water-sensitive design is a key driver. And to get to that point, I looked at understanding the performance targets that were present in media, literature reviews. I, of course, looked at investigative tools such as baseline investigations and data gathering. I looked at independent variables, and then I looked at dependent variables, which were community engagement and expert engagements. And that took the form of a redefinition of practice and how you can move from initiation to closeout traditionally versus how you can move into initiation, viability, and iterative design development using the community to, engagement to reframe how to approach design. I also looked at how that could then lead to a circular economy and how you can get into use, reuse, and phasing upwards of design. Right, so we then, I managed to get experts together, a panel of experts together, and there was a discussion over the different elements of the area that could benefit from water-sensitive design, as well as identifying areas that were important and areas that could be linked to with intervention. I then engaged with the community, well, with residents, not necessarily the community, with residents and members of the area. We managed to create, together we managed to create a revised diagram that looked at all the different levels of engagement with the area. That took this shape, where we looked at layers of information, security, fire. We looked at the possibility of implementing fire stations and how that could be received. We looked at the opportunities for reservoirs, community, and we identified where the community would center its activities, and then we looked at recycling methods and water retention methods and possibilities for artificial wetlands in the area. That resolved itself into a series of proposals. I named them Intervention 1, 2, and 3. And Intervention 1 is a system of, is a complex system that connects to the environment as a threshold intervention. This threshold intervention has a information center, a satellite fire station, and of course, how those systems would work with a dormitory to allow for training as well. And this was designed as a building that would touch lightly on the environment and would also integrate with sustainable systems and sustainable materials, so that you can consider this as a flagship for the project. I'd imagine this as something that would be rolled out as phase 1. And then we would move into phase 2, where there would be transitional interventions, allowing for people to move into these buildings that would be phased up. These are called the CI livable units. And those units, identified in yellow here in this diagram, would have a series of levels that can be integrated and can be developed depending on the use of the family that's involved. This district was also allowed for an activity hall and a youth center. These were programs that were identified by the community as things that they needed, things that they would imagine would benefit the area, as well as a police station with a observation tower that also acted as a green agricultural intervention. And the CI livable units have 3 phases, as you can see here. These are the systems that were in use, where we kind of quantified the amount of water retention as well as the amount of water, the water administration, how much savings could be calculated in 1 unit, and then how that could be carried forward. And the same was done for energy, where we, savings were identified in terms of use of a solar geyser as opposed to not using a solar geyser, using a centralized system so that you can not rely on the power systems that are present. And then, of course, there was the identifying of public buildings as sources of energy for the entire district. This is an analysis of the sun hours and the kilowatt hours of exposure that are present on the youth center building, which would then start to act as a power generator for that area. And then that got taken to the next level, which is intervention 3. In intervention 3, we looked at maximizing the area and developing high densities and trying to ensure that the highest amount of people could benefit from generation and water treatment. And these are diagrams that describe how that would be achieved in the mixed-use central system, which is this building over here. And you can see it here in section. And then that was then communicated into the community hall, which was more focused on how we can use technologies creatively, using low-embodied carbon materials like timber, low-intensity brick, as well as using passive heating and passive cooling and decentralized water treatment, which would be situated in a centralized water system there. Then, of course, I've got water concept diagrams that talk about how these intervention systems would work cohesively from source, collection, building utilization, and then output effluent. And these systems would connect to one another and would then eventually find their way back into the natural environment after being treated and being naturally run through a series of systems of aquifers and swales. And this is how that all came together. Sorry. And this is how all of that comes together. And then in conclusion, these became the key findings were that there are 2 sets of barriers that are in the way of implementation of water-sensitive design in low-income areas. The first set of barriers was established systems are, of course, the convention. We rely on established systems. Financial barriers are present. Not many people understand how to financially motivate such a program. There are social precepts of this system being expensive, the system being impractical, of course, because the amount of change that would have to take place would be a lot of innovation. And of course, there's technical operation barriers and existing policy that seem to be in the way. However, that perception is, the core of barrier set number 2, which is that there's a perceived cost construction, perceived cost conversion, and a perceived difficulty in adaptation, when in truth, once implemented, these systems could then start to feed into a rolling forward of improvisation and innovation. So in totality, the research itself found that there are some barriers that are present, and for us to get to a water-sensitive, livable environment, we would need to succumb these barriers and then find a way to engage in sustainable practices whilst addressing these issues for people to buy in and to accept the changes. Thank you.
Great. Amazing presentation, Chisomo. Well done. Well done. Well done. This is an amazing solution that could benefit our environment, and is hitching on the United States Sustainable Development Goals, which is what is critical to us, right, as World Technology Partner. That beautiful presentation right there. So, ladies and gentlemen, we've heard from Chisomo, and as the second round winner, we are going to be heading on to our first place winner, which is okay. Before I go into that, do we have any questions? Quickly, if there is any question from the participant, from the audience, quickly, please just indicate by raise your hand so that you can ask the Chisomo right away. If you couldn't unmute your mic, you could drop your question on the chat box for him. Right. I believe that Chisomo has done justice to his presentation. So we'll be moving ahead to our first placed winner for 2024 Green Sustainability Trends, right, by World Technology Partners. And I'm glad to call on Karen Bottis, postgraduate PhD in landscape architecture University of Pretoria. She will be talking to us today on the research proposed guideline for outdoor modular living wall system and African vegetables for improved performance as edible growing infrastructure. Ladies and gentlemen, I present to you Karen Botes. Karen, are you there?
I am here, yes, thank you.
Welcome.
I'm just going to share my screen. Everyone, I'm Karen Botes I recently completed my PhD in landscape architecture at the University of Pretoria in South Africa. I did my research on the southernmost tip of the African continent, like Chisomo. My study area is the Future Africa campus of the University of Pretoria. It's South Africa's capital city, which is located in the Gauteng province of South Africa. So why South Africa and why food security? So currently, 20% of Africa's population is malnourished, with nearly 690 million hungry individuals in 2019. The number of people facing hunger in Africa is expected to double by 2050, with an estimated 300 million people in sub-Saharan Africa at risk of food insecurity by 2030. So my research analyzes the performance of outdoor modular living wall systems with African vegetables to improve household food security in South African urban environments. So first I need to clarify two definitions, and the first is modular living wall systems. They are living wall systems that comprise planter boxes or pots attached to walls or building facades that contain the growth medium for rooting plants. And then African vegetables are green leafy vegetables that are naturalized and adapted to Africa or selected for their local conditions. So the SDGs I looked into was food security mainly, but we cannot look at food security in isolation. So climate action impacts on food security. Over the last 2 decades, the global climate has changed in such a way that it's affected all of our lives. Climate change impacts the prospects of achieving all 17 of the SDGs, either directly or indirectly, and especially food security. There's a link between food security and no poverty, and also responsible consumption and production, proved by research. And I also explored good health and well-being, gender equality, decent work and economic growth, sustainable cities and communities, and life on land to have a two-way link between ending hunger and reducing food insecurity. So due to the increasing atmospheric carbon dioxide levels over the last years, we experience extreme climate events with substantial economic losses for most global economies. And the changing climate conditions impact food supply and productivity. And especially in Africa, climate change has a devastating impact on food security. And this contributes to growing food insecurity and poverty. Looking at the South African population, there was a 1% increase from 2023, with the population currently standing at 62 million people. And then the Gauteng province dominates internal migration, with more than 2.4 million international migrants from the SADC region. Approximately 55.5% of the South African population is living in poverty, with a total of 25% who are experiencing food poverty. These issues intensify food security and the related SDGs. So my research focus areas was, number one, the contribution of urban small-scale food production to household food security and interrelated SDGs. 2, the performance of outdoor modular living wall systems as edible green infrastructure. And 3, the performance of African vegetable crops in modular living wall systems for household food security. So looking at focus area 1, food security and related SDGs, in inner cities, the potential area for facade greenery is almost double the footprint of buildings. That's why I looked at living walls. And living walls offer ecosystem services which are vital to sustainable cities. If we incorporate small-scale food production in living walls, we can address food security, cooling, reduce carbon dioxide, provide habitats, and benefit our health and well-being. Then looking at focus area 2, the living wall performance, current changes with living walls, you can see the high inset costs, maintenance requirements outweigh their benefits in total. They are not resilient with a restricted planting palette to survive the stresses of an urban environment. So my study involved the construction of 2 selected systems. The first system on the left-hand side of your screen is the vicinity system, and it presents a high technology system. The second system on the right-hand side, the eco-green wall, is a low technology system. The control was a natural soil area in which the crops were planted in a conventional agricultural convention. Then area number 3, African vegetables. The global system relies on only 30 crops now for the nutritional requirements of the human population. This makes our food systems very vulnerable to climate variability, especially in developing economies like sub-Saharan Africa. So the human population will be more vulnerable if one of these crop species falters due to climate change. One of these strategies entail the reinvigoration of African vegetables to improve diets and their sustainable use. So due to time constraints, I'm not going to go into all of these, but the study monitored 9 African vegetable crops over a period of 6 months between 2020 and 2021. I looked at various variables. I compared the biomass and plant stress for the different typologies and the crops. And my other variables include minimum and maximum daily temperatures, relative humidity, precipitation, soil temperature, water content, and electrical conductivity. And then I analyzed the data statistically. Going into the conclusions, so in addition to the biophilic benefits, living wall systems with African vegetables as an urban agriculture solution offer ecosystem services. They can therefore be considered a sustainable food system option to address food security and related SDGs globally, and especially in the sub-Saharan African environments. These sustainable urban agriculture solutions, such as living walls with African vegetables in marginalized communities, such as sub-Saharan Africa, can contribute to food security and the related SDGs. Then the second finding from my study was that outdoor modular living walls with African vegetables can contribute to local household food security as edible green infrastructure in urban environments. And I specifically looked at Gauteng, but it can be applied in many countries. So this chart compares the typologies concerning the fresh monthly yield performance per square meter in horizontal footprint. So it shows that living wall systems are more effective in space saving of a horizontal footprint than traditional soil-based food production on a household scale, as the natural soil area produced the lowest yield per square meter considering the footprint. So the vicinity wall, the black wall, was the most productive by producing over 5 times the yield of the natural soil area, whereas the eco-green wall, the low technology wall, was over 2 times more productive than the natural soil area. Then looking at the performance of living wall systems. So the system has to have components manufactured from cost-effective recycled or reused materials. It must preferably be locally manufactured. It must be a low technology system with uncomplicated assembly with robust components, and materials must be lightweight. Also, the study proposes plant pots with a soil volume of at least 3 liters and a depth of 200 meters. And this is important because it increases the yield and reduces the plant stress. Selecting suitable crops increase the crop performance, resilient and social benefits. And the soil must also be suitable for the crop requirements. Then a basic drip irrigation system must be provided for each plant level. This contributes to reduced costs and carbon footprint. And lastly, the system design should avoid open reservoirs and filters to reduce maintenance. Then 7 of the African crops that I looked at showed potential. And due to time constraints, I'm just going to flash through them quickly. Otherwise, I will exceed my 10 minutes. Thank you very much.
Come on. Thank you very much. Excellent. Excellent presentation, Karen. Excellent presentation. Excellent solution. Yeah. So thank you very much for the awesome presentation and solution, to our environment. Like again, I mean, this is another solution that is also profound to us. I mean, this is what we are advocating for to see around the world at World Technology Partners, right? So now we are going to be taking questions for the next 3 minutes. If there is any question for Karen, please do well to raise up your hands and so that you can ask your questions. Heman, do you have any question?
No, I'm just preparing for my next presentation. Thank you.
Right.
Well, it's very great presentation. Thank you, Dr. Karen.
So we are still waiting for questions for Karen regarding our presentation. So don't forget to take some screenshots as our presenters, our winners are presenting. Take screenshots, right? And try to make the world know what you are doing. Let the world know what the solution, the agenda that World Technology Partners are trying to push, right? Post on your LinkedIn, post on your Insta, post on your Facebook, talk about the event, talk about tag World Technology Partners, right? So that others will also benefit from this conversation in the nearest future. So still waiting for questions. Okay, at this juncture, I observe that there is no question for Karen. So permit me to move on to the Distinguished Faculty Award, right? So let's make some noise for the Distinguished Faculty Awardees. So we're gonna be going right into it, right? I'm going to be calling on Herman Darwish, Assistant Professor, Department of Architecture, right, from Ain Sam University, Egypt. She's going to be presenting to us on utilizing date palm ridges in low-cost, light, wide-span shading structures and refabricated wall panel structure depending on traditional techniques. Ladies and gentlemen, I present to you Assistant Professor Herman Darwish. Welcome, Prof.
Welcome. Thank you. Thank you for the great introduction. Is my slide showing now?
Yes, you can see.
Yes,
it's
thank
live.
you. So Hello, this is Dr. Iman Darwish. I'm an assistant professor in the Department of Architecture and Engineering at Ain Shams University, Cairo, Egypt. And I'm here to talk about utilizing date palm raches in low-cost shading structures and prefabricated walls using traditional techniques. First of all, I'd like to express my deep gratitude for being selected for the Distinguished Faculty Award, and I hope I give a fruitful and eye-opening speech. My colleagues who spoke before me from Nigeria, Ethiopia, India, and South Africa, we all share the fact that the agricultural sector plays a major part in our economies. And with this comes the huge burden of wastes that ought to be used in the most efficient ways, one of which is organic architecture. And therefore, although I'm about to talk about an agricultural waste that is prominently exclusive to the Middle East and North African region, I believe the concepts I will present can be reapplicable for a wide range of agricultural wastes you may find in our countries. So about the date palm, 16 million date palms are distributed in Egypt along the Nile Valley, North Coast, and Sinai, making Egypt the 5th richest country in date palm numbers in the world. And each palm undergoes annual pruning to boost the quality of the date. The pruning process produces around 20 old dry raches per palm. And this is a raches. It is the rib in the middle of a branch from the crown of a date palm. And since the time of the ancient Egyptians, raches have been used in numerous handicrafts, furniture, and doors. All these are images from the National Egyptian Museum in Tahrir, and with the techniques being used until now. The door on the right is from the Middle Kingdom and the ancient Egyptian era, and this door still uses the same technique and the same components and can be found in the contemporary villages in Fayoum and Upper Egypt. And they also have deep connections to our culture. The bottom images are from Nubia, where the palm raches is a strong element in their culture, and the top images are from the Coptic Christian festivals in Egypt, all also holding the palm raches in their hands. Now, let's look more closely at raches. So raches is the long rib flowing along a palm leaf with a length up to 8 meters and a diameter range from 1 to 7 centimeters. Fiber bundles extend along the raches without much interlinkage in between, and the bundles are the densest on the outside, which explains why raches is traditionally used without peeling to preserve its strength. The fibers being the sole medium to channel the forces makes the strength in the longitudinal direction far superior to that in the perpendicular direction. This is the main issue we must consider in any design concept that uses raches. So we'll need to look for a structural component that has the ability to transform all moments to axial stresses, so the fibers can carry them efficiently without failure. And such components include trusses, which uses hinge joints and bracings to eliminate moments. Moreover, shaping an arch to be parabolic transforms all stresses on it to pure axial compression. So we thought that what if we begin with a truss and then arch it into a parabolic truss, so everything on it is axial compression. Then make it into a space truss to have higher strength and wider spans. Then shorten the bracings at the top for higher stiffness and lengthen the bracings at the base for higher out-of-plane stability. So this was our first concept, the tri-arch space truss. And this is a maquette that we built using date palm raches cut into scale, so we could understand more the scale of the elements to be used in bigger laboratory specimens. And this was building these specimens. It was 1:3, the scale, with a span of 2.8 meters. And the specimens were built by local craftsmen who enriched the design details with their expertise from the traditional handicrafts they deal with every day. And these were our 3 specimens, and each specimen was built in under 1 day, reusing members from the previous specimens, because as we'll see in the next slide, failures were exclusive at the top parts. So every time the top parts were simply replaced, and voila, this is the new specimen. In the laboratory, they showed high flexibility and safe failures. Failures were marked when we began to hear tiny cracks in the top parts, and the models popped back up after releasing the modes. The experimental behavior was compared and used to validate the digital finite element method model, and this was then used to predict the performance at the span of 12 meters, proving to be safe. And so the design, the tri-arch space truss, can be used as the main chords of light tensile structures like tents, like this, these little tents made here. Or it can be repeated in both directions, and to make cross bolts with different alternatives, as shown in this maquette. Also, everything we made a maquette for. And each design alternative of these can be used for low-cost, fast shading structure for multiple purposes. But this was my PhD, actually, but I found problems at implementing them to build them in the one-to-one scale, because they're monolithic structures that must be built one-to-one to actually investigate its performance. So we said, why not? Why don't we shift to a smaller assembled unit, something that employs the concept of prefabrication. And actually, prefabrication is not too far off traditional practice. Traditional handmade furniture, like those on the left, or the fences and huts in the middle and the right, are traditional fences made in Upper Egypt and the oases in the Upper Egypt, and they are all made by assembling separate lattices. Each lattice of them is made separately, and then they are assembled to make the whole product. So currently, I thought about using the details of the traditional handicrafts and employing them in a new design. The new design of a wall, a prefabricated wall panel that can be used and made and moved and used and assembled to make a shelter or a house or whatever. So the details of the wall were inspired by details from the traditional furniture. And as we said previously, Rachis is panel to carry these loads. So the longitudinal members, the vertical members, must be left intact without any piercings, without any damage to the fibrous structure. But they can be driven through the piercings in the secondary horizontal members, as we see here. And at the top of the panel, the top plate was duplicated to distribute the loads more evenly. And this is also inspired from a shoe rack made of the palm branches in the right. And at the core of the panel, additional vertical and horizontal frames and diagonal bracings were added to enhance the stability and shear resistance. This detail was simply employed and inspired by beds made of date palm branches. Also, they understood, even the illiterate craftsman and his nature understood how he must fight the shear and create some shear resistance, and this is what we learned from him. And this was a detailed handbook that I made to guide the craftsman through building the panels, written in Arabic, of course. And it was through linking the details to the daily details they deal with in traditional furniture or fences or traditional work. And these are details of the first real scale panel, which shows the interlinkage between the outer faces and the internal frames. And these are the photos of the completed walls from all sides. So the artistic skills of our craftsmen can obviously shine from the sides, as we see here in the middle and the top of the wall. We can see here also that the walls show sufficient stability and rigidity, and also the craftsmen we hired to build them admired the easy, straightforward, and fast execution process. And using the validated properties, a finite element method model was simulated for the wall, and it showed promising performance as a wall panel and as a roofing panel. So at the end of this presentation, it's worth noting that this methodology of form-active structural conceptualization can be replicated for any other long fibrous agricultural waste, such as reeds, thin branches, giant reeds, bamboo, with proper adjustments to the natural physical properties of each type. Also, I'd like to say that this research emerges as a response to Sustainable Development Goals. These goals include empowering rural communities for a sustainable construction that harmonizes with their very delicate nature of their environments. Also, it introduces a new versatile field to reuse reaches safely. This safer method saves the environment from the hazardous pollutants and greenhouse gases produced from the annual burning, because usually most of the pruning procedures of date palm end up being burned, because only 10% are used in the traditional furniture, the things that I showed you before, but mostly they are burnt to clear the fields fast, so the fields can be used for other things. So this is actually a better way of using them as wastes. And also, these trials aim to help substitute wood to fight irresponsible sourcing of the extremely scarce wood forests, because in Egypt we don't have a lot of forests, and all our wood is very scarce, and sourcing them is dangerous to the environment. And I believe this can be also said for the sub-Saharan region in Africa. Future studies will aim to further investigate the structural and economical feasibility of date palm raches wall and roofing panels to be used in the range from prefabricated housing to fast crisis shelters. Also, their potential use for energy efficiency by adding insulations is yet to be studied, in a long journey that we hope it would result in an international patenting of the designs. Finally, I'd like to acknowledge the interdisciplinary guidance by my professors from Ain Shams University, Professor Yasser Mansour, Department of Architecture, Professor Hamid Al-Mosli, Department of Mechanical Production Design, Professor Zamra Abdurrahman, and Ayman Mustafa from the Department of Structural Engineering. And that's it. I hope we can get in touch and collaborate soon. Thank you.
Woo, amazing. That is the final presentation from our distinguished faculty awardee, Ayman Dawis, Assistant Professor, Department of Architecture in Sam University, Egypt. Well done, Prof. So, do you have any question from the participants? If there is any question for Prof, please raise up your hands and let's give it a shot. We have 3 minutes to ask our questions. So I believe Assistant Professor Herman has done justice to our presentation. So ladies and gentlemen, and this is the final presentation from our awardee, right, from the first the third place, second place, first place, and the final the distinguished faculty awardee, right? So, and it has been up to an hour and 17 minutes on this call, and it's been an impactful one. I could see some comments on the chat box. I mean, this is a very powerful presentation, very powerful solution that will impact our world. I mean, we are so glad to have you people, right? Excellent professionals, right? Academias that are working on real-time solutions that could benefit our environments. So we really want to appreciate you for your work, and we urge you to continue, digging deep into solutions like this that could actually benefit our solution and the rest of the world. So don't forget, most importantly, take pictures before you leave. The session is not yet closed, right? But don't forget to take pictures, right, of you. You have to turn on your camera, take pictures, post on LinkedIn. Let people know what you are doing. Let people know the agenda that we are trying to push at World Technology Partner. So at this juncture, I'm going to be handing the mic to my director, in person of Paul Frank, to take up the conversation from there. Hi, Paul, are you there?
Yes, Habeeb, I'm here. Thank you very much for your help today. And I want to, basically we are over time. We did want to discuss some other things, including the UN's World Restoration Flagship Program, but we'll do that at another date later on. In conclusion, identifying and addressing major sustainability challenges are vital for achieving Universal's targets by 2030s. Some of the previous efforts discussed today help in that regard. Collaboration, cooperation, and global efforts are crucial to overcome these challenges effectively. We want to thank everyone who joined us today, our presenters, our audience members, our judges who helped us make these selections, and we hope you'll stay tuned for news of our upcoming annual competition and an announcement of other upcoming webinars, including, as I mentioned, efforts in the UN's World Restoration Flagships. Thank you to our presenters and our audience, and have a wonderful day. A copy of this webinar will be on our website probably by Wednesday morning. Thank you again, and thanks again to our presenters. We'll be talking to you soon. Everyone have a great day and stay cool.
Thank you, everyone. Thank you so much for coming on the call.